Hi team, good evening. Welcome to the demo class on data modeling training. So before starting my demo, I would like to brief about myself. I'm native from Maharashtra and currently I'm working with Generative Analytics team. Prior to that, I used to work with Oracle and before that I completed my master's from NIT Nagpur. So since then, from 7 years, I'm working on developing data pipelines and data modeling requirements for various industrial requirements. So with this, we can start with our demo class. So as part of this demo session, we'll be covering introduction to data modeling. What are the various types of data modeling and various techniques to do the data modeling. So with this, we can start. Before it's like whenever we are saying that I want to start with data modeling, we should know what is the data modeling and why it is needed first place. So data modeling is just a process of creating visual representation or building any information system or any subpart of an enterprise system. When we say information system means anything which we do online. Like whenever any business wants to come up with some online solutions, they need to have an information system to store all the transactions and all the attributes, whatever things they are doing or selling over online. They need the data for that. And in order to store the data, we need a data model. So that entire requirement has been shown as a pictorial representation using data modeling. So that is where data modeling comes into picture, like what it is. Whenever any business user or tech user comes with, they want to build an information system, the first thing will come into picture is like, tell me what are the entities or what are the data points you want to store. It will give a holistic approach or holistic view for a entire business requirement. And then it comes like why data modeling is needed, because when it comes to software lifecycle, so basically we are building a software for which we need a data model. So when we say software lifecycle, we have different stakeholders. First is the business user, who is going to put the money or his own business requirement into the system for building the information system. Second is the developer, who is going to develop that requirement, and third is the end user, who is going to use the end application. So in order to cater all three people, different people, we need to model it well so that each and every individual will understand what they need to, what role they need to play. When it comes to business user, he will need a holistic approach. He want to know what my entire system is about. What are the different data points are present in the system? What are the informations I can drive from the system? What are the business rules I can implement? All those things should be all those things should be present in the data model so that business people or business stakeholder are convinced that yes, whatever problem statement was there in the mind is going to be solved using this data model. Then second person is like developer or your infrastructure team who is going to implement that business model. So they will need some precise details like how to implement that requirement into a system, a software system. So they will need some different view or some more granular details about the entities. So that's where we come up with the various types of data models. So types are nothing but abstraction. So based on the abstraction level, we go on evolving our data model. So first abstraction is like conceptual level, that is basically used at the time of requirement gathering. And the most of the person who are going to take part into these are business stakeholders and users who are going to tell their requirement or going to tell their problem for which a BA, business analyst, or some software company is going to provide a solution. So while talking with the business user, tech user, we need to be more in the business terms. We cannot use technical terms because those people may not be from the technical background. So in order to cater their needs, we need a very abstract view of our system. So that is being provided by our conceptual model. So when we are saying data model, it is actually a roadmap for any organization's information system development, because that is going to define like what are the things our entire system is going to hold and how it is going to evolve in the future. So based on the various requirements, we will have various different models, because we may customer requirement can be anything. Someone wants to have the online transaction system. Someone may need to have analytics system. So like they just want to do some analysis. Someone may need to have some predictive system. So different business requirements will be coming in, and in order to cater such business requirements, we will have different level of abstractions, different level of technologies coming into picture, and different level of users who are going to contribute for building that entire system. So data modeling is very crucial for any business requirement because it is going to lay down the roadmap for your entire system. Because when you start developing an entire system, just assume it is like a foundation for building any new construction building. So if your foundation is not correct, whatever building you're going to build, that may not hold the expansion. So the way businesses goes in like over 5 years or 10 years life cycle, their growth or their success depends on the initial data model, what they used in the start. That's why data modeling is very much crucial in terms of business, in terms of development, or in terms of growth. So that's why everyone wants to know about the crux of data modeling and where they can contribute for it. Because depending on the user, their contribution changes. Like any other design process, like we design is a common concept for any engineering activity. If you are a civil engineer, you will be designing the architecture. If you are a chemical engineer, you will need the design for your setup or your whatever experiment you are going to provide or chemical compositions we are going to do. So design is like a common term needed for any engineering activity. So same goes for our information system design. There will be some standards. We need to get into some standard rules, regulations, so that your system should be robust, and those will be running up, and with the expansion, those will not crash, or those will not need a scratch development from the scratch. So with based on all these variations and views and abstraction levels, data models are categorized into three parts: like conceptual data model, logical data model, and physical data model. Conceptual data model is the abstract most level, like first level when we start the requirement gathering. It actually it's the entry point for any organization to have the new information system. It is also called as a domain model, which gives information about the entire domain, or what the system is going to hold, or what are the relations among those data points what are present into that information system. Next comes the logical model, which is more grainer, or like we can say a little less abstract. Conceptual was very much abstract, where we just know the entities, what is the data it is going to hold. But when it goes to logical modeling, there are less abstract and provide more information about the concepts and relationships. So when we are saying that we are going to hold some data points into a system, we should define the relationship. How these data points are related, what will be the relationship among those data points, and what are the different operations we are going to perform on those data points. So after completion of this all three types, we will walk you through one example where we will exactly precisely know how this conceptual model, logical model, and physical model differs, and what are the different users coming into play with those. So conceptual model was basically for business tech users and end users, and logical model was basically more over for business analyst and dev team, where they can connect and get more understanding about the entities, their relationship, and their attributes. So when we are saying that logical model, we'll be talking more granular level, where we know what are the entities and what are the attributes we are going to store as part of the information system design. And then it comes with the third model, physical model, which is the least abstract model, where we have all the precise details about the entire schema, what are the attributes, what is going to be their maximum length, minimum length, what are the different constraints, and what will be the what we can say relationship among those entities. Like it might be one to one, one to many, many to many. So all those details will be available in these data points, where we are going to have the physical model. One more thing about physical model is those are like target system based. Means when we are saying that our physical model is ready, it means we are uh, on the conclusion of our tech stack also. What is the target system we know. Based on the target system, we are going to define all the schema definitions, the attributes, its columns, its relationship, key attributes, constraints, and all those things. So when we say that we have the physical model ready, that means our application can be started for development. So in order to understand all these three models from a simple example, let's take an example of any sales store. Suppose a business is there, it's have the store across the world from in various countries, and they are selling some goods. Now the store owner wants to have some analytics system. He just want to know what is the sale for each center based on some data parameters and what are the different products sold from those centers. So this is the basic, like what we can say, very crude or open ending business requirement where they come up with some conceptual model. So when first business requirement came in for this conceptual model, from the business statement itself, we get to know that when they are saying that their presence is in multi countries, we need to have some information regarding the store details. What are the locations, what are the countries, and where the stores are located. When they are saying that they have various product lines, because they want to know what are the products getting sold in particular running in particular country and what are the products not country. So they are going to have some information related to products. So basic measure they want to check is the sale. So there will be information for sale when we are doing any sale. There will be some transaction information. So we need to store the sale information as well. And when they are saying that they want to know about the dates and monthly, quarterly, yearly sale, we need to store the time information. So basically, from this business statement, we can decide where we can deduce that okay, for this business statement, at least minimum we'll be having 4 to 5 entities where I need to store the sale information, I need to store the region information, I need to store product information, I need to store time information. So this is more over like a conceptual model. So with this model, we can start like then yes, business owner will say that okay, yes, I can say that this is like for a particular store, I can restrict to what are the products available in that store based on the country restriction. Then for the sale, I can store the sale information for all the stores, all the products in one location because sale is like a standard invoicing which is used across the countries. So we can keep those details. And time will be the common because dates are not going to change across the world. So this document will be speaking more about what are the entities or what are the data points present into my conceptual model or my business requirement. So when once we get closure on this, like this, business person and business analyst both are saying that these are the only data points which we are going to store in our system. Then comes the next step, logical model. Then why logical model is needed? Because when I'm saying I need to store the product information, I should know what is the information I'm going to store for the product. When I'm saying product, there will be some product name, there will be some category, subcategories, and there will be some product code which can be used for tracking the code across the countries because name can be different. Like suppose some word is said in English, it might be differently pronounced in the French, Japanese, or Chinese. So they need to have a common code for them to identify the product. So when I'm saying about product, I will need to store product name, product ID, its category, subcategory, its pricing information, like pricing information, its manufacturing date, when it was manufactured, and its shipping details. So where else it can be shipped, what are the countries it can be sold, because those kind of restrictions might be present. So now when I'm talking about a product as an entity, I came up about the attributes, 8 to 10 attributes, which are associated to a product. Next comes the store or region. When I'm saying region, what are the attributes I need to store? I need to store the country name. If it is across continent, I need to store the continent name. Then from continent, country, I will have to store the state, city name, its store location, store address, and along with that, I will need to have some store number to identify all the stores across the globe which are present in our business chain. So these are the attributes we need to store, we need to keep in our data model, we need to store in our information system related to store. Then comes the sale. When I'm saying sale record, I need to store my first action, generating some invoice number. I need to have some pricing information because every country will have some different pricing and currency information because the payout will be in that country's currency. So as part of the sale record, I need to store the invoice number, product details, its currency details, what was the price given. If there are some discounts provided, I need to store the discount information and final net amount paid. Then someone may ask like, what about the taxes? So if that should be the clarification from the business requirement. So if they are saying that yes, we have the taxing information in our system, or we want to store the tax details, then we need to include the tax information as well in the sales invoice details. So when I'm saying sale as an entity, These are the different attributes I need to store in the important system. And then comes the time as an entity. So time as an entity, we need to store the date, year, month, quarter, because that is needed for your aggregations. Suppose someone wants to know the quarterly sales, yearly sales, half yearly sales, or weekly sales, or bi-weekly sales. All those granulations and roll-ups can be done using that timetable. So now I got these four tables, like product as entity, sale as entity, store as entity, and time as entity. Next thing comes up is the what is the relation. A product can be present in multiple stores. Yes, that is possible. A store can have multiple products. Yes, that is also possible because store is not going to sell only single product, right? So it is like many-to-many relationship. A sale will have the time relation because we need to store what are on what day the sale happened. Sale need to have the product information because we need to know what was the product sold and what was the amount. And we need to store collect the store details also because that sale was done from which store, that should be known. So for sale is having one-to-many relationship with the time, product, and store, because sale can be for multiple days, sale can be from multiple products, and multiple stores can have the sale on the same day. So when I'm ready with the logical model, these are the details I know. I know what are the entities in my system, what is the relationship among them, and what are the attributes I'm going to store. Then comes the least abstract level, that is our last model, which is physical model, where we talk about the our target system based on what are the stack we are going to use or what is the grain we are going to use. Like I say, just said that menu-to-many relationship is there, mean my product and store, or my sale and product is one-to-many. So I need how to define this relationship. So in order to define this relationship, I need to come up with some foreign key or primary keys. So all those key constraints can be defined based on the what is the database system or information system we are going to use. So that is the details present in our physical model. When I'm saying my physical model is ready, it means I have the schema which I can deploy on the target system. Whether it might be the database system or it might be some programming language or it might be some XML or something, whatever data model, data technique we are going to use. That I'm going to provide as part of my physical model. So this gives an overall view about what are the different models and how those models are catering the business requirement. Conceptual model, logical model, and physical model. So it's like we are like step by step we are peeling the onion. First we got the conceptual model, then we got the logical model, last one was the physical model. So then the third part of our course outline was like we got to know what is the data model, why it is needed, what are the different types. But along with that, when we go with the implementation, when we have got the different use cases for data models. So implementation varies based on the technology. It is needed because your each and every application cannot be like one to many or many to one. So when I am talking about the data modeling techniques, they are basically broadly categorized as 5 data modeling techniques, like a relational data model, hierarchical data model, object-oriented data model, network model, and ER model. So we can name based on some different technology. If we are using something different stream structure or something, we may have some different kind of methodology. But if you go like in general terms for the software development or any business requirement development, these are the 5 basic categorizations available based on the techniques used. So we'll go with the first, the basic one, which is like relational data model. And one more clarification here, it is needed like these all different data models are not like apple to apple comparison. We cannot compare relational data model with a hierarchical model or a hierarchical model with a network model or object-oriented, because the entire business use case is different, technology stack is different, or the requirement is different. So we will go one by one and just get the brief about what that model is about and what are the general use cases where we can use that model. So most traditional and the most used model is the relational data model. These are widely used for modeling any transitional systems, where we can represent all the entities in terms of tables, and the relationship can be represented using the keys, primary keys, foreign keys, where we can define one-to-many, many-to-many relationships. The relational models implemented using mostly some database systems like Oracle database, SQL Server database, or some MySQL like open source relational databases. Then next comes hierarchical model. So this is specifically for the data points where my requirement is hierarchical. Means my one data point is related to many child data points. So it forms a tree. So moreover, tree-like data structures or tree-like information is being stored in a hierarchical model. So for this means very best example for this XML database. So when I'm saying XML databases, these are mostly nested, where I have some parent node and I will have some child attributes. And this was extensively used in 80s, where we got these hierarchical data points, and many of the systems were built on top of XML. Even still, if you see some of the softwares, we will have some XML configurations for the softwares where we feed in some properties or some configurations for running the tool. So those are the examples of hierarchical data model. Then third comes the object-oriented model. Object-oriented data modeling came with the what we can say rise of the object-oriented programming, which focus was moreover on the inheritance, encapsulation, and abstraction. So all those things were provided as part of the class object structure. So those same things we got inherited into the data model also, because when I'm saying I'm defining an object, I'm defining object using the class definition, where I will have some defined attributes, some functionalities which can be actioned by the class, so that its actual representation was taken care by as the creation of the object. So creating objects based on class definition and implementing abstraction, inheritance, and encapsulation, all those things as part of our middle layer for any application development. That was the moreover explained by using object-oriented model. When we are developing an information system, it's not always the database only. It can be the middle layer where you are actually doing the programming using the Java or .NET or some Python, where you need to build the objects, you need to define the attributes, and those objects and attributes are stored into the backend system. So the object model comes in the middle layer when we are implementing in a transaction system. Then next comes our fourth is the network model, where we are dealing with the data points where one node can be joined with multiple nodes, and those nodes can be joined with another nodes. So if we remember, previous one was hierarchical, where we have only tree-like structure. There was no reverse joins. Like one parent node was there, and we have some children node, and that was the only mapping we know. That was the only relationship between the data points. But when we say graph level, graph like we will have the edges. A node can be connected to multiple nodes, and that node can be connected to many other nodes. So in order to represent such graphical data points, we got the network model. Network data model can be very easily explained using graph databases. So Neo4j is one of the famous example, which is like a network data model where we store the graphical information. LinkedIn is basically completely built on top of a network data model, because LinkedIn doesn't store the data in terms of like table where we use relational, or in terms of XML or a hierarchical model, or it doesn't store in the objects. It store it as a network. So that's why whenever we visit any LinkedIn profile, we get to know the connections, common connections, and it represents as a graph. Actually, that graph is being stored in the backend graph database. Neo4j is a database used for that, and there are many other graphical databases available which we can explore for such requirement. And then last comes with the ER model. ER model is like an entity relationship model. This is basically used as a conceptual level. So if you see what are the all five models we discussed. So some models are for conceptual modeling, some are for logical, and some are for physical. So relational model was for physical, hierarchical model was for logical, object oriented was also for logical. Network was more over on physical, because we were representing the data as a graph. And now comes the ER model. ER model is for conceptual modeling. So when I'm saying ER model, it is basically high level relationship model between all the entities or elements that I'm going to use in my system. So with the example of what we saw earlier, like a sale details for any enterprise application. So ER model will be like, I will have some relation, I will have four entities: sale, time, product, and store. And there will be relationship among those one to one, one to many, and many to many. Those relationship we will be representing into ER model. That ER model is actually the output of our first conceptual design when business tech user and our design PAs, we are discussing the requirement and they are jolting down all the data points or the entities, what are the rules we are going to incorporate in the design, what are the restrictions we want to have. Like suppose we are saying that we are building the sales system and we haven't stored the quantity of a product. It doesn't make any sense. Building the entire sale application, we don't know the quantity available in the store and the store is going to do the sale entries. That system will crash because we don't know what is the available quantity. So as this comes as a part of a design model when we are modeling the entire system, these things should be discussed and these things should be modeled in your data points. So that's why data modeling is very crucial for implementation of any information system. Either it might be OLAP, it might be the OLTP, or it might be mobile application, or it might be any online system which you want to use. So when I'm saying any online system which I want to use, I need to store some data, I need to store some details. And that entire storage need to be have some structure. And that structuring is nothing but data modeling. So with data modeling, we get to know what is the crux for any application, what is the design or what is the business impact that application is going to have. And in the start, as I mentioned, based on the data model, based on the foundation, we can decide the growth of the company. Like suppose the data model we built for a country level and we don't store the container details. Adding the container information will be very easy, but changing those attributes, existing attributes, their data types or details will be very hard. So that's why data modeling has been considered as a crux for any development activity or any design activity. So with these details, we got to know why data modeling is important for any business and how it delivers the entire software life cycle and eases the development process and brings the transparency. Because how we are bringing the transparency? Because we have this like abstraction was broken into three parts, like step by step. First, we have the conceptual model, then we have the logical model, then we have the physical model. So, at least at the one of the steps, we should be capturing the details where there might be the crash of the application or where we might be missing some of the information that need to be stored in the system. So, this is going to give you like a blueprint for your application development or roadway for your entire IT infrastructure development. And one more thing is like the more graceful your data model is, more flexible your data model is, you are going to evolve your system or integrate your system with another subsystem. Like when we are building an income system for enterprise, it's not only a single business requirement or single data warehouse. There might be multiple data warehouses, like various business lines, business units, and they might want to get common output from all the data warehouses because that is what needed for the business. Because the business is having, suppose they are having working in the 10 verticals. At the end of the VP level or organization head level or board level, they need to know what is the revenue from all those 10 verticals. So the data model developed for all those 10 verticals should have some common point where they can communicate, where they can get the details which are needed for the board at the 10 vertical levels. So with this, we can close on our data modeling introduction. I hope you got to know why data modeling is needed, what is the data modeling, and what are the various techniques where data modeling is, using which we can do the data modeling. So along with this introductory session, you can start on reading about what are the ER design techniques needed for OLTP and OLAP application. When I'm saying OLTP and OLAP, these are basically transaction systems and analytic systems. Both requirements are different, business use cases are different. So ER diagrams will be different for those. So you can go through the details on those, like what are the different ER techniques for those business requirements, and those can be explored using some open source tool. We have models here as open source where we can create some ER diagrams. We have draw.io, which can be used for building new ER diagrams and getting hang on what are the conceptual modeling is looks like and what are the relationships we can define over the ER model, like one to one, one to many, many to many. In the session, I have given one example about sales, where I have went through a conceptual model needed for a sales application, logical model, and physical model. So as part of the project, you can go with the one example building all three models, conceptual, logical, and physical, for online exam system. You can take online exam for like some graduate students or some engineering students or a particular normal MCQ exam, whatever use case you want to define, but get the precise business statement and build all three models around that. And another project is identify different entities and the relationship for building e-commerce application. So while building e-commerce application, what are the entities involved in an e-commerce application, basic e-commerce application? What will be the relationship among those entities and how its physical model looks? So I hope with these two projects, you will get a hang on all data modeling logics and what are the techniques which you can use for data modeling, and you can answer some of the questions around data modeling. Or whenever someone asks you to build some data model, you will know what are the steps. First, you need to come up with a conceptual model. Second, you need to have a logical model, and third is physical model, which you are going to deliver. So around those three modeling techniques, you will have some questions in your interview or wherever you are going to build the data model. So with this, there are some certifications which you can explore. Some certifications from IBM, some are from AWS, and there are some certified courses on Coursera where you can go and get the graduation certificate from it. So if someone interested in getting certified in data modeling, they can go with this. With this, I would like to close the session. If you have any questions, any doubts, you can reach out to the email provided in the slide. Thank you.